Hello. In this video, I will show you 3 examples of the equation of the circle, how to work with the equation of the circle. So we have the two different forms of the equation of a circle. We have the center radius form, where we know the center and the radius, and sometimes you will see the general form of the equation of a circle. When you FOIL the x minus h squared and y minus k squared and group like terms, you get an equation like the one in the general form. Now, this equation may not necessarily represent a circle. It may be a point if the radius in the center radius form is 0, or it may not have a representation on the coordinate system if the radius is negative. So we're going to do the first example. We have an equation that is in the form of the general form of the equation of a circle. Determine whether the equation has a circle as its graph, and if it does, determine the center and radius. So what we're going to do is group like terms. That is, we're going to group the terms with x and the terms with y. And then we are going to complete the square. Okay, so I'm just rearranging terms. X squared plus 8x. I'm rearranging terms and grouping like terms. So that's y squared minus 6y. And that 16, we're going to pass it to the other side. So all I did was rearrange terms. So next, we are going to complete the square. So the expressions within parentheses become perfect squares, perfect square trinomials. So we need to divide, in the first expression, we need to divide 8 by 2 and square it. So that's going to be 8 over 2, that's 4. And then divide 6 by 2 and square it. 6 over 2 is 3 and square it. And to keep things equal, what I'm adding to the left side, I need to add it to the right side. So that's going to be minus 16 plus 4 squared plus 3 squared. I need to keep things balanced. And then factor the perfect square trinomial. The first one will factor as x plus 4 squared. The second trinomial will factor as y minus 3 squared. And then 4 squared is 16, so negative 16 plus 4 squared, that's negative 16 plus 16. Those cancel out, and 3 squared is 9. And that's it. We have the equation in center radius form, where h is negative 4. Remember to change the sign. H is negative 4. Y is not y. K is 3. And r squared is 9, which means that r is 3. And that's it. The radius is negative 4, 3. The radius is 3, and the center is negative 4, 3. Okay, next example. We are going to find the equation of the circle. With center at negative 2, 5. And passing through the point. 1, negative 3. Okay, so we are going to use the center radius form. The center radius form, remember, this is x minus h squared plus y minus k squared equals r squared. Okay, so we know, good thing, we know the center. The center is negative 2, 5. So we know that h is negative 2 and k is 5. And we also know some point. Some point 1, -3. So x is 1 and y is -3. So we are going to plug in these numbers to obtain the square of the radius. So let's do that. R squared is going to be 1 minus -2 squared. So this is positive, so that's 1 minus -2 squared. And then y is -3, and k is 5. So that's -3 plus 5 squared. This is what? This is 1 plus 2 squared. And then plus -8 squared. But 1 plus 2 is 3. -8 squared is -8 times -8, so that's 64. And 3 squared is 9, so 9 plus 64 is 73. We're going to keep the equation in center radius form. So the equation of the circle is going to be what? It's going to be x minus h. So minus -2, that's going to become plus 2. And then y minus 5 squared. And the square of the radius is 73. So that's the equation of the circle in center radius form. Enter the example. This example is going to put together the distance formula and the midpoint formula. We are going to find the center radius form, of the equation of a circle, having a diameter with endpoints 1, -2, 9, 7. So we don't have a lot of information. We just know 2 endpoints of a diameter. So sometimes it helps to draw a picture. So we got 1, -2. And then we have 9, 7. So these are the endpoints of a diameter. I don't know what the circle looks like. All I know is that these are the endpoints of a diameter. I don't have a lot of details. But if these two are the endpoints of a diameter, the center is going to be the midpoint. So the midpoint, so the center is the midpoint. And the radius is half a diameter. So we can do it two ways. We can find the midpoint, but in case the midpoint has a fraction, we can find the distance between the endpoints of the diameter and then divided by 2, and that's going to be the radius. Okay, so yeah, so the radius, we're going to, so to find the radius, it's half the diameter or half the distance between the given points. Okay, so let's find the center. So it's going to be the midpoint. So the x coordinates are, I'm going to write this down. This is 1, -2, and 7, 9, or 9, 7. Okay, so that's going to be 1 plus 7 over 2, or 1 plus 9 over 2. That's the x coordinate, and the y coordinate is negative 2 plus 7 over 2. So 1 plus 9 is 10, and negative 2 plus 7 is 5. So this 5 halves, I'm going to keep it as a fraction. The center, it's 5 halves. And then to find the radius, we are going to find the distance between the points with the distance formula and divide the distance by 2. Okay, so the distance, or that would be the diameter, we find this with the distance formula. This is going to be x1 or x2 minus x1, so that's 1 minus 9 squared, or 9 minus 1 squared, plus 7 minus negative 2 squared. So this is the square root of a squared, plus 7 minus negative 2 is 9, so that's plus 9 squared, where 8 squared is 64 and 9 squared is 81. And 64 plus 81 is 145. Okay, so that's the diameter, and the radius is going to be half of that. The radius is the square root of 145 over 2. Okay, so we have the center, we have the radius, and we're going to put this together to get the center radius form of the equation of the circle. At the end of the equation, it's what? It's x minus 5 squared plus y minus 5 halves squared equal to the square root of 145 is going to be 145, or the square root of 145 squared is 145, and 2 squared is 4. And that's it. So this is what we wanted. Okay, this is it. Thank you for listening.